Hello, this is Dr. Keith Miller again. In the last module, we looked at the formation and classification of igneous rocks. In this hands-on video, we will be looking at the formation and classification of sedimentary rocks. Sedimentary rocks are formed from the weathering products of other rocks. Weathering involves both the chemical alteration and dissolution of rocks, as well as the mechanical breakdown of rocks at the Earth's surface. These various weathering products are then transported by the agents of water, ice, wind, together with gravity, and accumulate in a wide variety of depositional environments. In these environments, transported sedimentary grains are cemented and compacted to form rocks, or dissolved ions carried in solution are precipitated out to form rocks. So, let's look at the products of weathering a little closer. Igneous rocks are the most abundant rock types in the Earth's crust by volume. So we will consider how different igneous minerals weather. Mafic minerals, such as olivine, pyroxene, or amphibole, rapidly weather chemically to produce dissolved ions in solution. So we will use this beaker of water to represent ions that are dissolved in solution and carried in solution from the place of weathering. Other more silica-rich felsic minerals, such as feldspar and mica, will be chemically altered to form clay, as well as dissolved ions. Quartz is a very resistant mineral to chemical weathering and will typically remain unaltered for very long periods of time. Mechanical weathering will break down rocks into individual mineral grains or rock fragments, such as seen here. So you have both rock fragments and mineral grains of various sizes. The harder minerals, such as quartz, will tend to survive mechanical breakdown longest. We can thus group the products of weathering into dissolved ions in solution, again represented by this beaker of water, clay, mineral grains, and rock fragments. Sedimentary rocks that are formed by the precipitation of minerals from ions that are dissolved in water are called chemical sedimentary rocks. And in front of you is a selection of chemical sediments as well as chemical sedimentary rocks. These include evaporites, such as halite and gypsum, that precipitate out as water is evaporated. Imagine taking a beaker of salty water and letting it slowly evaporate. As that water evaporates and the concentration of ions in the water increases, mineral salts would begin to precipitate out. So that you would then get things like evaporitic rocks, such as we have here. These are all evaporitic chemical sedimentary rocks. Chert can also be produced by the chemical precipitation, in this case, of silica, the same composition as quartz, and like quartz, it would be hard and resistant. Even some types of limestones, such as oolitic limestones, can also be precipitated chemically from the water. Another type of chemical sedimentary rock is biochemical. Most limestones, for example, are biochemical because they are produced by the activity of calcite-secreting organisms. Everything from corals, such as we see here, to clams or bivalves, to snails or gastropods, and any other calcium carbonate skeletal secreting organism. And this would even include things like plankton, microscopic plankton, or even algae. These calcium carbonate skeletal materials are then broken down biologically and mechanically to produce carbonate sands and muds that are then cemented to become limestone. And here's an example of a carbonate sediment. These sediment grains are all calcium carbonate. They're all tiny fragments of shells and other skeletal calcium carbonate skeletons, from large pieces of shell to sand and finer sized materials. And again, those can then be cemented to form limestones. Chalk is another type of limestone that's also produced by microscopic calcareous plankton. So it has this very fine-grained texture. Chert that we've seen before can also be formed by the accumulation of microscopic silica shells of certain types of plankton. And in that case, chert would be biochemical. Another sedimentary rock that can be considered biochemical is coal. Coal is produced by the heating and compaction of accumulated plant material, what's called peat. By contrast, sedimentary rocks formed from the eroded and transported mineral grains and rock fragments, as well as clays, are called clastic rocks. The term clastic means broken, and refers to the breaking and abrasion of rocks as well as minerals and rock fragments by the processes of mechanical weathering. Clastic rocks are subdivided based on the size of the grains forming them. For example, at the finest end, we have clays, and clays feel slippery or sticky, and the grains are much, much too small to see. Rocks consisting primarily of clay are called shales if they are finely layered, or mudstones if they are not. The next size up grain is silt. And silt grains, while granular, are too fine to see the individual grains, but they feel gritty to the touch, so you can feel them even though you can't see the grains. And rocks formed from silt are called siltstones. So again, this has a gritty feel to it even though you can't see the individual grains. The next larger size are sand grains. Now sand grains are big enough to see, so you can see the individual grains, and range up to 2 millimeters in diameter, about the width of a pencil lead. And rocks formed by the accumulation of sand are unsurprisingly called sandstones. Finally, at the coarser end, we have gravel, sediments that are larger than 2 millimeters in diameter. And rocks formed from gravel are called conglomerates, or if the grains are angular in shape, breccias. So again, here you can see the individual grains, large size grains, being cemented together to form this coarse-grained rock. In the next hands-on video, we will see how clastic sediments change from the place where they were produced by weathering to the places of deposition hundreds or even thousands of miles away.